trying to find the equation of the tangent line to this implicitly defined function at this point here. So use implicit differentiation, put the 2 in front, we get 6. Leave the inner function alone, x squared plus y squared. Lower that power by 1, multiply by the derivative of the inner function. That's going to give us 2x plus 2y. Remember that the derivative of, or that y is a function, so we have to multiply that by its derivative, dy dx. Okay, right side, similar. We're going to get 25 times 2x minus 2y, and again, derivative of y, we need that, dy dx. We'll go ahead and expand this left side. Let's distribute that 6 in there first, so we're going to get 6x squared plus 6y squared. This will stay the same. Okay, and then the right side, distribute that 25, we got 50x minus 50y dy dx. Okay, left side we'll expand this using FOIL. We're going to get 12x to the third. Outer term 12x squared y. And then a dy dx on that one. Inner 12x y squared. And last term 12 y to the third dy dx. Right side stays the same. Okay, now we have to get all these dy dx terms to the same side. And one thing we can do to make this tiny bit easier, notice that everything, all of these terms have something that is divisible by 2. So we'll go ahead and move all the dy dx terms to the same side. And at the same time, we're going to divide all of this by 2. So all these coefficients are going to get cut in half. So we're going to get 6x squared y dy dx. That's this term. That one's also on the left side. We'll leave it on the left side. Divide that coefficient by 2. 6y to the third dy dx. This term over here, we're going to bring that to the left side too. We're also dividing that coefficient by 2, so 25y dy dx. Bring the other terms to the other side. So it's going to be 25x. That's this term here. Coefficient divided by 2. This over here, minus 6x to the third. This term here, minus 6x y squared. We brought all these dy dx's to the same side so that we could factor out the dy dx. So once we do that, we're left with 6x squared y plus 6 y to the third plus 25y. Right side stays the same. And then finally we will divide by all this stuff here on the left, so dy dx is equal to 25x minus 6 x to the third minus 6x y squared divided by all of this 6x squared y, 6y to the third, 25y. Okay, so this is the derivative, and we need this to find the slope of the tangent line. M is going to be equal to whatever we get when we plug in that point, so 25 times 2 minus 6 times 2 to the third power minus 6 times 2 times 1 squared divided by 6 times 2 squared times 1 plus 6 times 1 to the third power plus 25 times 1. If we put all of that together, you get negative 10 over 55. So the equation of our tangent line will be y is equal to negative 10 over 55 x plus some b value. You can find that b value by plugging in the point again, so we're going to get 1 is equal to negative 10 over 55 times 2 plus b. Solve this for b, that's going to be negative 20 over 55. Add that to the other side, I'm going to get 1 plus 20 over 55 is equal to b. And actually, before we add these together, let's just realize that we can divide both of these by 5, so it might be a little easier to say 1 plus, if I divide that by 5, I'm going to get 4 over 11. So 1 plus 4 over 11 is equal to b. Adding these together, this is 11 over 11 plus 4 over 11, that's 15 over 11, so b is equal to 15 over 11. So the equation of our tangent line is going to be y is equal to negative 10 over 55x plus 15 over 11. So a lot of work to get to that point. And let's just realize what we just did. This thing is the graph of a lemniscate. It looks kind of like an infinity sign. If we look at that particular point here and we graph that line, we will see that this line will just glance this function at that point. And I've actually graphed this on Desmos so that you can take a look at it and verify graphically that we have the right thing. So this is the lemniscate that I was talking about. It looks like the infinity sign. That's the graph of this implicitly defined function that we've been working on. And if you graph the tangent line that we just found, you can see what happens right at that point, 2, 1. Indeed, the tangent line really does just glance the function right at that point. So we've got a visual confirmation of our solution.